Hello students. So today's session we are going to see how to construct a binary search tree given the traversal. Okay. So last session we had seen how we can um, search for a node, and we also saw how we can delete a particular node from the binary search tree, and we saw a couple of cases like node with a single child, node with no child at all, or node with two children or two child nodes. How we can do that we have seen, right? So now let us see, given the traversal, that means you will be given the in order, pre-order or the post-order traversal, and then from the traversal how we can construct the tree. Okay, so let us take an example. Let us say the in-order traversal is given to us. Okay, so this is the in-order traversal. That is the in-order traversal. Now with only in-order we cannot construct the tree. Either we should be given the pre-order or we should be given the post-order. Okay, for this example, pre-order is given to us. That means in-order traversal is given. Pre-order traversal is also given. Okay, pre-order traversal is this is the pre-order traversal. Now, given these two, how can we convert or construct a tree? That is what we are going to see. As I told you, only with in-order you can't do. You should have either in-order and pre-order, or you should have in-order and post-order. Either of them you should have, only then you can construct the tree. How to construct this tree now? Now, if you look here, whenever you have done the pre-order traversal, okay? Pre-order means what? Root, left, right. Alright. So, pre-order traversal always starts with root. Pre-order traversal always starts with root of the tree. So, given that this is the pre-order traversal, we have P here. So, P is the root of the tree. Okay. So, you can simply blindly put P as the root of the tree. Am I clear? Pre-order traversal always begins with root. So, whatever is the first one, that is nothing but the root of the tree. So, I can simply write P as the root of the tree. Okay. Next. Now, given P, if you look at the in order, whatever is left of this P in the in order is the left subtree. Whatever is to the right of the P in the in order should come to the right of the tree. Okay, so that much is clear now. Now, so this part I can put it as left subtree. This part I can put it as right subtree. So, I will just put down that T, S, Q, A, E, D. This is left subtree. And then I have M, X, C, R, F. This is the right subtree for now. Okay. Next. Again in this, T, S, Q, A, E, D. Which is coming first in pre-order. That is what you have to check. T, S, Q, A, E, D. This part. Correct? In this part, which is coming first? A. A is coming first. So, I would consider A as the root. Alright. So, now if A is taken as the root, with respect to A you see here, TSQ is to the left of A, ED is to the right of A. So, I can write here TSQ is to the left of A, E and D are to the right of A. Again, if you observe TSQ in the pre-order, S comes first. So, I will take S is the root of for this. If you see here, in case of in order, T is to the left of S, Q is to the right of S. So I'll have here T, this will become Q. Similarly, ED which is coming first? E. So E will become the root node. D comes, if you look here, D comes to the right of E. So I will write E. So that is our left subtree is now ready. Similarly, we have to write with respect to the right subtree. Now, if you observe MXCRF, okay, if you observe this part now, let me take up this part. MXCRF, correct? Which is coming first? X is coming first. Here. So, X becomes your root. Okay. Now, you see X here in case of in order. What is to the left of X and what is to the right of X? So, what is to the left of X? It is M. What is to the right of X? It is CRF. CRF. Alright. Now again, out of this, which should be the root, which should come left, which should come right, we do not know. So we look into the preorder. CRF, you see this part. CRF. R is first. So R is first means R is the root. Again, see the in order. C is to the left of R, F is to the right of R. So C is to the left of R, F is to the right of R. This is how it is. So let me put down the entire tree now. So I started with P, okay, and then we had A, right? Then we had S, then we had T and Q. Alright, again right of A is E, right of A is E and then followed by D. So E then followed by D. Come to the right side, P. So after P I will write X. X, right, left of X is M. Right of X is R. Alright, and then we have C and F. C and then. So this becomes your tree given the traversal. I hope I am clear. We will take one more example. So this is one more example. We are given the preorder, we are given the in order. In order is written next, in order is there, preorder is. In order compulsorily it is required. Either apart from in order, you should have either pre-order or you can also have post-order. Two of them should be given, otherwise you cannot construct a tree. Okay, so now let us see. So as I said, pre-order always begins with the root. So we can immediately identify which is the root. So which is the root here? 1 is the root. So I can simply write 1 as the root of the tree. Okay. Now come to in order. If my 1 is here. Whatever is to the left of 1, I will put it as left subtree. Whatever is to the right of 1, I will put it as right subtree. Okay. So in that case, what will happen? I will write here 8, 4, 10, 9, 11, 2, 5. All these are left subtree. Then what do I have at the right side? 6, 3, 7. This much for now. 6, 3 and 7. Next. Out of 8, 4, 10, 9, 11, 2, 5, I will look into the pre-order. This is my left side, is it not? Out of this, in the pre-order, which is coming first? 8, 4, 9 up to 5. Which is coming first? 2 is coming first. So, 2 will be the root. Okay. Again you come back to in order. 2. What is to the right of 2 is 5. Left of 2, the rest all will come to the left of 2. So, 8, 4, 10, 9, 11. All this will come to the left of 2. Now, observe this part. 8, 4, 10, 9, 11. 8, 2 is over. 8, 4, 10, this part. Which is coming first? 4 is coming first. Correct? So 4 will become the root out of that. Now if you look at 8, 4, 10, 9, 11. 4 is done. If you look at 4, left is 8, 10, 9, 11 is on the right. So I will write here 10, 9, 11 will come on the right. 8 is on the left. So I will write 8 on the left. Again, 10, 9, 11 I should see. 10, 9, 11 if you see here, 9 is coming first. Correct? So 9 will be the root. Again here, if you observe here, left is 10, right is 11. So left is 10, right is 11. We are done with the left subtree. Let's move to the right subtree. 6, 3, 7. Look into the preorder. 6, 3, 7, which is coming first? 3 is coming first. So 3 will be the root. 3 will be the root. Again, look into the in order. 6 is left, 7 is right. 6 is left, 7 is right. If I try to rewrite this tree again now, how can I write it? So 1 is the root, then I will write 2, then 4, then 8. Okay? Again, right child of 4 is 9. Again you have 10 and then you have 11. 2 has 5 here, so that also will come here. Again come to the right side. I have 3 and then 6 and then 7. So this is how my tree is going to look. So given the preorder and the in order, how can we construct a tree? Let us take one more example. In this example, we are seeing, we are given the in order. I said in addition to in order, we should have either preorder or post order. One of them we should have. Last two examples we saw, we were given in order and preorder. Now we are seeing in order and we are given post order. So how to construct the tree? Everything is the same except that preorder I told it begins with the root. Correct? Post order means what? Left, right, root. Post order ends with root. It ends with root. So whatever is the last element of the post order, you can take that as the root of the tree. Are you clear? Preorder means the first, it starts with root. So the first node you are taking it as the root of the tree. Post order ends with root always. So whatever is the last element of the post order, that you are taking as root of the tree. So we have taken root. Everything else is the same. We have taken 8. So whatever is left of 8 will come as left subtree. Whatever is right of 8 will come as right subtree. Okay. So here I have 9, 5, 1, 7, 2, 12. All this will come as part of my left subtree. Right subtree I have 4, 3, 11. This will come as part of my right subtree. Next, out of 9, 5, 1, 7, 2, 12. That means out of this part, 9, 5, 7, this part. 9, 5, 1, 7, 2, 12. This part, I have to find out which is the root, is it not? So again, this is post order. Whichever is coming last, that you should take it as root. Which is last in this? 5. So I will write 5 as the root. Again, go to in order. If you look at these elements, 5 is here. Left of 5 is 9. Rest all is coming right of 5. So 1, 7, 2, 12, all these are right of 5. Okay? Again, I am done with this part. 1, 7, 2, 12 I should see. 1, 7, 2, 12. If you look at 1, 7, 2, 12. Which is coming last? 7 is coming last. So 7 will be the root. Again, go to in order. Look at these 4 elements. Left of 7 is 1, right of 7 is 2 and 12. So left of 7 is 1, right of 7 is 2 and 12. So if I look at 2 and 12 now, I will look at only these. 2 and 12, 12 is last. So 12 will be the root. To the left of 12 is 2. So 2 will come here. So that's how you try to. Now we are done with left subtree. Let's move to the right subtree. 4, 3, 11. 4, 3, 11. If you look at that in the post order, 4, 3, 11. Which is last? 4. So 4 will become the root. 4, 3, 11, if I look here, yeah, 4 is last. To the left of 4 is last. Okay, 4, if you look at 4, 3, 11, both are coming to the right of, what to say, 3 and 11 comes to the right of 4. So I will put 3 and 11 here. Okay, next, if I look at 3 and 11 here, this part, 11 is the root because 11 comes last. Look at 11 here. Left of 11 is 3. So 3 will come. So if I try to rewrite this tree now, I can write 8. Left of 8 I have 5. Right of 8 I have 4. Let me finish the left side. Again here I have 9. Then right of 5 is 7. Left of 7 is 1. Right of 7 is 12. Left of 12 is 2. That is your left subtree. Coming to the right side, 4. Right of 4 is 11. Left of 11 is. So this is the tree given the post order. So whenever post order is given, you should always take the root. It ends with root. So you should take the last element as the. One more example we will see. Okay. So in this example again, we are given in order and post order. Right? So post order means what? It ends with root. So I should take the last element, whatever is there in post order traversal, as the root. So what is there in the last element? 40. 40 is the last element. Correct? So I will take this 40 as the root of my tree. 40 is root. Now, if I go to in order, whatever is left of 40 will become the left subtree. Whatever is right of 40 will become the right subtree. Alright. So, I will write here 3, 10, 17, 25, 30, 32, 38. All these are left of 40. Right of 40 we have 50, 78, 93. Probably you can pause this video and do it for yourself and then check with mine. That will be better. Okay. Anyway. So then, now we have written 3, 10, 17, 25, 30, 32, 38. Out of that, come to post order again. 3, 10, 17, 30, 38, 32, 25. Up to here. 50 comes on the other side. Up to here. Which is coming last in this? 25 is coming last. So 25 will become the root. Because it is post order. Now come back to the in order. 25 is the root. Whatever is left of 25 is left subtree. Whatever is right of 25 is right subtree. So what will happen here? I will write this 3, 10, 17. They are all left of 25. Right of 25, what do we have? We have 30, 32 and 38. Okay. Next. Again come to 3, 10 and 17. 3, 10 and 17. Which is last? 10 is last. So 10 will become the root. 10 will become the root. Come back to in order. 10 is the root. Left is 3, right is 17. Okay. So left is 3, right is 17. Okay. Next. Let's come to 30, 32 and 38. Come to post order. 30, 32 and 38. Which is last? 32. So 32 will become the root. 30, 32 and 38. If you look into the in order, both 32 and 38 okay, 32 is the root. If you come to in order, left of 32 is 30, right is 38. So this will become 30, this will become 38. So we are done with the left subtree. Let's move to the right. Right, what's happening? 50, 78 and 93. If you look into the post order, 50, 78 and 93, 78 is last. So 78 will become the root. Go to in order, 78. 50 is left of 78, 93 is right of 78, same thing we put here, 50, 93. So this becomes your final tree. So if I have to write my final tree, I'll write 40, we have 25 on the left, let me finish left subtree, 25, then you have 10, then we have 3, then we have 17. Okay, after 25 we have 32, 30, 38. Coming to the right subtree, we have 75, 50, 90. So this becomes your tree, final tree, given the in order and the post order. Alright. So this completes your concepts on tree. So we have seen, we started with definition of tree, we saw what are the terminologies used in tree, we saw what are the types of different types of trees, we saw what are the different types of binary tree, then we saw what operations can be performed on a tree, then we saw how to create a tree, what is binary search tree we saw how can we do traversals, different types of traversals, we saw a couple of examples. We also took up a program which is there as part of your lab cycle. And then we saw how to search a node, how to delete a node, and how to construct a tree given the traversal. So this completes your chapter on trees. Okay. So I will end this session here. I will see you all in the next session. Thank you.